Hey everyone, Joe Shap here, and today I'm going to break down the process of building factories for advanced materials in StarRupture. This video aims to teach you how to build clean and efficient factories with ease. I'm going to make a factory that makes hardening agent as an example. This is a moderately complex product that uses all 5 of the different raw resource inputs that are currently available in early access, and it's a good product for illustrating some key ideas which are transferable to any type of factory you might want to build in StarRupture. Hardening agent is used for the Tier 8 contracts for 2 different corporations, Clever Robotics and Future Health Solutions. It is also an ingredient for several even more advanced products. To prepare for building a new factory, I use the crafting calculator linked in the description to determine which raw materials I need and how much of each of them. I also use this page to get a rough idea of how many buildings I'm going to need. Some of the buildings won't be in the factory, like the extractors. For the numbers next to the buildings, the whole number tells you how many of each building type you'll need. You can ignore the number in parentheses. This is just telling you how many machines you would need if you could use fractions of a machine, because some machines won't be running at full capacity. There are a couple other really useful sections on this page. One is this items required section, which shows you how much of each item you'll need. The other useful section is this main section, the selected items. So we've selected the hardening agent, and we could edit the rate at which we want to produce them, but we'll just do 30, which is how much it does for one furnace. You'll notice this arrow, which allows you to expand and see what items are used for the recipe to make the hardening agent. You can keep doing this all the way down until you get to the basic ore. This is a very useful way to see how things combine, but you'll notice there are times where synthetic silicon is needed for the hardening agent, but it's also needed for the chemicals. For now, let's decide where we want to build our factory. This interactive map, which I've linked in the description, can be helpful for finding a location for our factory and where to get the raw materials. I like to hide everything on the map besides the resources I'm looking for. I've decided to use this location because it's pretty close to every resource I need, and it has a nice big open area that's decently flat for us to build on. Once I've decided on a location, I like to set a foundation of platforms to build on. I try to make it bigger than I think I need it to be, because I don't want to run out of space. Quick note that whenever we're building, we want to have an inventory full of plenty of building materials. For the foundation of platforms, if I can just use supported platforms, I will, but sometimes they can't reach the ground, so I'll lock the Z level by pressing Y, I'll throw down some individual supported platforms, and then I'll cover the rest of the area with regular platforms. Next, we need to get our raw materials to the factory. In this case, we need titanium, wolfram, calcium, helium, and sulfur. For the ones that can go in a smelter, we can optionally do the smelting close to the source to save a bit of space at the main factory. Consider using cargo dispatchers and cargo receivers if the materials need to travel particularly far. Let's get into the factory, starting with the titanium. I have the titanium ore coming into a storage depot so that the smelters can request the ore straight from the storage depot, and then the depot can request to get refilled from the ore extractors. For this build, we need 2 smelters, and we're not fully utilizing them. In particular, this one, they can each make 60, but this one is only doing 30, which it's using to make 60 titanium sheets. The full smelter is used to make 30 titanium rods twice, so 60 titanium rods total. Both the sheets and the rods are flowing into fabricators to make tubes. Making one rail connector shorter than the other is one way to easily get 2 inputs into a machine. The tubes then flow forward to create applicators along with glass. The glass is actually coming from a cargo receiver. A cargo dispatcher on the other side of the factory is sending these over. This means that there's one less rail line that needs to come across the entire factory, potentially causing clutter and mess. Now let's talk about the Wolfram. It is also using a storage depot as a buffer. This time we only need 1 smelter, and that smelter is going into 2 furnaces that are both making Wolfram powder. The Wolfram powder has to come over to the other side of the factory. Also, side note, as you can see, I made the factory much bigger than it needed to be. It was somewhat of an accident, but it's a much better problem than the opposite, where you don't have nearly enough room for everything you need to build. So let's see where the Wolfram powder is going. Some of it is coming right in here to make ceramics. The rest is coming forward to make chemicals. Now let's talk about our calcium ore. This is coming from pretty far away, so I'm using a cargo receiver. to get this into the factory. We only need one smelter for this. And this smelter is making a few different things. It's making calcite sheets, and then twice it's making calcite powder. The calcite sheets are only used for making ceramics. The calcite powder is used for a few things. A lot of it goes towards this class, which is then going into this cargo dispatcher to go to the other side of the factory. The rest of the calcium powder is going on forward. But before we get to that, let's look real quickly and see. This is also where the helium is coming from, and the helium is joining with the calcium powder on this one rail line. This is another way to get multiple inputs into a machine. Having multiple items on a single rail is handled well in this game, and I've made some videos on this. The one drawback that happens is that they share the throughput of your rail. So you want to make sure that the total amount per minute that you need on the rail is less than the amount that you can handle on your rail per minute. In this case, I'm not going over 240 per minute because I'm only assuming that you have rail v2. Again, using varied height rail connectors is proving to be useful. This time it's useful to pass through. Let's really quickly show how you make a rail connector change its height. So once you have it at the right level at a baseline, you can click the middle button, and then you can scroll it to go up or down. You will notice it turned red when I went down because it thinks that it's colliding with the platform. What you can do to avoid this is just delete the platform. Once the platform is deleted, this will no longer be a problem. Let's go back to the rail that's holding both calcium powder and helium. You can see it goes into this furnace to make synthetic silicon, and then it combines with this Wolfram powder rail and goes forward into this chemicals furnace. The synthetic silicon is also feeding into the chemicals. The synthetic silicon also feeds into this rail that has our applicators from the other side of the factory, and these both go in as two of the main components for our hardening agent. Here you can see where we have our sulfur coming in. And the only use we have for our sulfur is for the sulfuric acid. The sulfuric acid is one of the three things we need to make our hardening agents. And finally, we have our hardening agent. If you found the video helpful, liking and subscribing really helps out the channel. If you have any questions, feel free to leave a comment and I'll respond to as many as I can. Thank you so much for watching to the end.